Hello, my name is Scott Grizzard from the University of South Florida. This is for Calculus 1 for fall of 2020, and this is a supplement to Lecture 8B. In Lecture 8B, at the very end, I derived we derived arcsine. We found the derivative of arcsine and did a proof of it all in one go. And now we're going to do the exact same thing for arctan. So this is how to derive arctan and how to prove what the derivative is. We've got y equals the arctan of x. Thus, tan star of y equals tan star of arctan of x. And I wind up with tan star of y equaling x. Now, note here that this means y is an angle. And y is between negative pi over 2, pi over 2, not including the endpoints, because those are that's the domain of tan star. That's also the target or the range. Those two words don't mean the same thing, but that is the range of arctan. Okay. So now what I do is I just take the derivative of both sides. And then the difference is that now I'm going to wind up with something squared on the bottom. I'm going to wind up with a 1 over cosine squared. Okay, so that's a small change here from the other pattern, is that I wind up with something in a fraction. So here I'm going to do a chain rule, and I'm going to wind up with d over dy. Right, because this and that don't agree, and I can't have things that don't agree. Take the derivative of them, so I need to make them agree, and I use the chain rule to do that. So that becomes the tan star, the derivative with respect to y, and that's going to spin off a derivative with respect to x of y. Now, the derivative with respect to x of itself is a nice little convenient number 1. And now what I'm going to do is I'm going to go ahead and do this, and I'm going to use the 1 over, I'm not going to say secant squared, I'm going to say 1 over cosine squared, because I'm going to wind up multiplying both sides by that. So I'm going to wind up with 1 over cosine of y squared times dy over dx equals 1. And now what I need to do is I need to isolate, I need to get everything in terms of x. Okay, so what I'm going to wind up doing is I'm going to multiply both sides by this, by cosine squared, and I wind up with dy over dx equal cosine squared of y. So the question becomes, that looks horrible, the question becomes the following. What is cosine squared of y? Well, remember that y is the tangent here. So what my question really is, what is cosine squared of tangent star, of y is the arctan of x, cosine squared. So now I've got arctan here of x. And this is the kind of problem I need a triangle trick for. Okay? So remember, y is an angle. Okay? So here's my thing here, and y is an angle. And y equals, as an angle, the arctan of x. That means that x equals tan star, or just tan, because in this case it doesn't matter which one I'm using, of y. So here's y, and now I've got the tangent of y. Well, tangent of y, we're going to start by going after x. So in the simpler one for arcsine, it actually didn't matter which one we started with. We could start with the one we had, but now it really matters because we want this to come out cleanly. In order to make it come out cleanly, start with this thing here, this thing you're looking for. I'm trying to get x. Okay? So the tangent of y is the adjacent of y, if such a thing could be considered a function, over the, so it is the adjacent, I'm sorry, it's the opposite over the adjacent of our nice little triangle. Okay? So if I let the adjacent be, so here's the adjacent, here's the opposite, and here's the hypotenuse. Now, if I let the adjacent be 1, because that's the thing that's on the bottom, I'm going to make the opposite. So let adjacent equal 1, then opposite equals the tangent of y, which of course equals x. This is what we had up here. So what I'm going to do is I'm going to let this be 1. And I'm going to let this be x. And then I'm going to solve for the hypotenuse, right? That means that the hypotenuse squared equals the adjacent squared plus the opposite squared. A little Pythagorean theorem there. And the adjacent squared is 1 squared. Well, that's a nice little number. And the opposite was x. Which means the hypotenuse squared is 1 plus x squared. Now, I'm going to write that up here with a square root sign, but I actually don't really care about the fact that this is square rooted. I'm going to write that up there for the moment, but I don't actually care about it. This right here is enough, because remember, I've got cosine squared. Well, cosine of y, which is what I know, equals adjacent over hypotenuse. Okay. Well, the adjacent was 1, and the hypotenuse here is the square root of 1 plus x squared. So if I square it, because remember what I have is the cosine of squared, I have the cosine of squared. So if I square it, I get 1 squared over this square root squared again. That's a nice convenient number. Okay. So what I'm going to do is I'm going to use this right here. This piece right here goes back into that. So then I wind up with the following. I wind up with dy over dx equaling this bit right here, 1 over 1 plus x squared. So, d over dx of arc tan of x equals 1 over 1 plus x squared. Okay, so now when I go back up here, I'm going to want to write a want to show. Okay. I want to show that dy over dx, now that I know what it is, of arc, I want to show that dy over dx equals 1 over, equals, not of, equals 1 over 1 plus x squared. And my strategy take the take the tan star of both sides, here's what I need. I need to take the star, implicitly differentiate, And this time I'm going to say carefully use the triangle trick. Last time I didn't have to be so careful. And carefully use the triangle trick. And now I'm actually going to say it, because I'm going to say here it's important of what the first one was. So in my introduction, I need to remember that what I'm doing is using the triangle trick on x equals tan y, because that was really my starting point. On x equals tan y, letting the adjacent equal 1. Okay, so for me, I need to memorize that. Now, that might be natural for you. That's fine. For me, I need to memorize that. I need to set up that triangle trick on tan of y so that I'm starting with that. And then I let the adjacent equal 1. And then for me, it flows from that. Okay, that's it for the supplement. Thank you very much.